In this video, it's a continuation of the Test 3 review questions, and we're going to focus on questions 11 through 16, which deals with operations on functions. Now, functions are made up of variables and numbers that have been added or subtracted together or possibly even multiplied, much like an algebraic expression. And so we know that we can already add numbers and letters together. So we can add, subtract, multiply, and divide functions much like we do algebraic expressions. The notations change slightly, and that may be what may be giving you trouble. So in question 11, we have suppose that function f is 2x squared plus 3x minus 4, and that g of x equals 5x plus 2, and they want us to find f minus g at x. This is the indication of the operation. And basically what you have to do then is we're going to substitute x into function f, get an answer, x into function g, get an answer, and then subtract the results because that's the operation indicated in the notation. So if I substitute x into function f, I have 2x squared plus 3x minus 4. If I substitute x into g, I get 5x plus 2, and then I want to subtract those two things. But now remember to be careful because there's an understood 1 in front of the parentheses here, and we have to distribute that 1. So when I do that, I have 2x squared plus 3x minus 4 minus 5x minus 2. And then we come back and we combine like terms. There's nothing to combine with 2x squared, so I have 2x squared. We have positive 3x minus 5x, which would be minus 2x. Negative 4 or minus 4 and minus 2 would combine to give us minus 6. So f minus g at x equals 2x squared minus 2x minus 6. It's really a skill you already know because you're simply combining like terms. On question 12, they ask us to perform the operation of multiplication as noted by f times g. When you have it written inside the parentheses with no symbol between, that's an indication of multiplication. So we find the value of f, we find the value of g, and then we're going to multiply the two answers together. So for function f, we have 2x squared plus 3x minus 4. For function g, we have 5x plus 2, and then we want to multiply those two things together. And we used the distributive property to do that. Okay, so I'm going to distribute 2x squared first. So 2x squared times 5x is 10x cubed. 2x squared times plus 2 is plus 4x squared. I come back and I distribute the plus 3x. Plus 3x times 5x is plus 15x squared. 3x times positive 2 is plus 6x. I come back again and I'm going to distribute the negative 4. Negative 4 times 5x is negative 20x. Watch those signs. Negative 4 times positive 2 is negative 8. And finally, I come back and I combine like terms. I have 10x cubed, 4x squared plus 15x squared is 19x squared. 6x minus 20x is minus 14x minus 8. And that is the value of f times g at x. Question 13 asks you to do division. And division is indicated kind of by that slash mark. It looks typically it's going to be written like a fraction. So here again we find the value of f. we find the value of g, and then we divide, and it's written like a fraction. Now, since it is written like a fraction, you want to try to simplify if that's possible. Function f is, again, 2x squared plus 3x minus 4, and g is 5x plus 2. So it looks like a fraction. The quadratic, 2x squared plus 3x minus 4, does not factor, and so there's no way to simplify that, and that would be your answer of f divided by g. So when you're doing basic operations, remember you're basically going to be simply combining like terms after you've performed the indicated operation. The difference with beginning with question 14, that little symbol there with the little open dot means composition. And composition is something totally different from addition, subtraction, multiplication, or division. It's actually like a sequence of events, sort of like you're following a recipe and you have to do things in a specific order, which is indicated by the way the expression is written. So if we look at the expression f composed with g, that's how you read it, f composed with g. What that means is I'm going to take the value of x, substitute it into function g, get an answer, and then I'm going to substitute that into function f. So you kind of work your way backwards. You start with the x, plug it into the g, get the answer, and then plug that answer into f. And so I want to try to color code this so that hopefully you can kind of see what's happening. So we're going to write function f in red and function g in blue. So if we begin this process, we plug x into g, and we get 5x plus 2. That's my answer. I'm then going to take that answer and plug it into function f wherever there is an x. So we would have 2 times, and in place of x, we're going to put 5x plus 2. So I have 2 times the quantity 5x plus 2 squared plus 3 times that x value, and then the minus 4 is still tagged at the end. So again, in place of x, I'm going to put 5x plus 2. Then if we do the math, if we square 5x plus 2, we have 2 times 25x squared plus 20x plus 4. Distribute the 3 plus 15x plus 6 minus 4. Come back and distribute the 2. We have 50x squared plus 40x plus 8 plus 15x plus 6 minus 4. And again, the last step is to combine like terms. So we have 50x squared, 40x plus 15x is 55x, plus 8 plus 6 minus 4. 8 plus 6 is 14. 14 minus 4 is positive 10. So f composed with g is 50x squared plus 55x plus 10. Question 15 is also a composition problem, but notice it's written in a different order. In this case, they want us to take x, plug it into f, get an answer, and then plug it into g. It's a totally different order. You have to pay attention to the order. Again, let's use color code these as red and blue. So f is going to be red, and g is going to be blue. And I begin by substituting x into function f. When I substitute x into function f, I have 2x squared plus 3x minus 4. And then I'm going to take that answer, as yucky as it may be, and I'm going to substitute it into function g wherever there is an x. So I'm going to have 5 times, and in place of x, I'm going to put the value I got for f, which is 2x squared plus 3x minus 4. And then again, we need to simplify. We do the multiplication. 5 times 2x squared is 10x squared. 5 times 3x is 15x. 5 times minus 4 is minus 20 plus 2. And then finally, we come back and we combine like terms. So I have 10x squared plus 15x minus 18. Minus 20 plus 2 is negative 18. Finally, question 16, they're kind of asking you to work your way backwards. They've given you the final answer and they want you to figure out what two functions did you combine together. This one looks reminiscent of question 14, so you might want to look back at it. It looks like we took the function 2x plus 3 and we substituted it into x to the fourth minus 7x squared minus 8, so that we actually performed the composition of f composed with g at x. Now, honestly, if it's a multiple choice question on that particular type problem, just work your way backwards and see which composition gives you that result.